All right, everyone, in today's video, I want to talk about the characteristics of quadratic equation graphs. Man, that is a mouthful, but that's okay because it's only a few different pieces. We're just going to look at this graph and talk about some things about the graph. That's really all we're doing today. So what's one of the big things about the graphs of quadratic equations? Well, one thing, let's start with something familiar, the y-intercept, right? The y-intercept is where my graph crosses the y-axis. So here it crosses the y-axis, this point right here. So you would say the y-intercept is at 0, -5, or you might just say that it's -5 for the y-intercept. Okay, let's talk about something else. So that's the y-intercept. We also have the vertex. Now, you may have heard vertex before in talking about shapes. Those are like the points, the corners of a shape. Those are the vertices, or that is a vertex. Right here, the vertex is the point where my quadratic changes directions and it stops going down and starts going up, right? And in this graph, the vertex and the y-intercept just happen to be the same thing. That won't always be the case, but in this graph, they are. So the vertex here is the x and the y points, and here that's 0, -5. So that's my vertex. It's the point where the curve of my graph is. Okay. Let's talk about something else. Well, when, and we'll talk about it in relation to the vertex. If you have a graph that looks like a happy face, we say that that's, it's a positive quadratic function. Okay, if it looks like a happy face, this one clearly looks like a happy face, right? So it's a positive function, meaning that it opens upward. So if it opens upward, then it has what we call a minimum, right? And what the minimum is it's the lowest y value for my graph. So here, the minimum, the lowest y value would be -5. It would be y equals, right? At the point y equals -5. That's where my minimum is. Maybe it's best just to say -5. I'm not sure I like saying y equals -5, even though it is where the y point is. It is that y value -5. And notice that is the y value of my vertex, right? So the minimum is always the minimum, or we'll see in another case, the maximum is always the y value of my vertex. The other thing that I want you to think about, or want you to notice, is the axis of symmetry. The axis of symmetry, that M looks a little suspect, but that's fine. Okay, the axis of symmetry. What's the axis of symmetry? Well, the axis of symmetry is where you could cut the graph in half and it would be flipped on both sides, right? It's the line that makes my graph symmetrical. And here, sometimes you can kind of see it, right? Here, in this graph, it's straight down the middle. You can see it. It's straight down the middle, straight down the y-axis. That cuts my quadratic function in half. So the axis of symmetry here is this line. It's the x value of my vertex. It's this line that cuts the graph in half. And if you remember, vertical lines are x equals 0 for this case. And so just like the y value of the vertex gave me the minimum or the maximum, we'll see, the axis of symmetry is the x value of the vertex. Okay, so the y-intercept is where it crosses the y-axis. The vertex is that point where it curves. The minimum or maximum is the minimum, specifically, is the lowest point in my graph if it's facing upward. And the axis of symmetry is the line that cuts my graph in half. Let's look at one more example. Here, we've got a few things to talk about here. So first things first, let's look at the y-axis. Not the y-axis, the y-intercept. The y-intercept of this graph, if we look 5, 6, 7, if we look right here, my y-intercept is at the point 0, -7, right? So you would say the y-intercept is -7. Remember, the y-intercept is the point where my graph crosses the y-axis. Okay, what about the, what did we do next? I think we did the vertex. The vertex, that's the point where my graph curves, right? In the last one, on the last graph, right, my graph was facing upwards, so it kind of curved downwards here, or it curved at the bottom. Here, my graph faces downwards, so it curves at the top. Curves at this point right here. So that's 1, 2, 3. 3, x is 3, y is 2, so my vertex is at 3, 2. Sorry, those lines are kind of hard to see. So my vertex, that point where my graph curves, is at 3, 2. And this one, last time I had a minimum, right? I had a lowest point. This time I have a maximum or a highest point. So now my maximum is at the point 3, 2, right? It's 2. And you can remember, it's the y value of my vertex. It's this part right here is where my maximum is, right? My maximum is that at the vertex. And last but not least, the axis of symmetry is the line that cuts my graph in half. It's the x value of my vertex. So we go here. Would be the line across this point, the x value of my vertex. Oops, was kind of cool, but the axis of symmetry is x equals 3. Because that's the line that cuts my graph in half. Okay, one more thing that I kind of want you to note is these points where these points, and I'm not sure that they're actually whole numbers here. They might be. These points where the graph crosses the x-axis, my x-intercepts, we also call those roots of the equation because they form the base of my equation, right? Those are the roots of the equation. And we'll talk more about what that means in a future video. But for now, those are some of the key characteristics of quadratic functions.